1 second, what was it? 29. Okay, very good. Limit as x approaches 2 from either side, x squared plus 3x minus 10 over x squared minus 4x plus 4. Perfect. Okay. The first step, when we are asked to determine a limit, we will plug it in. You can say again, you're not allowed to. I will have to agree. I'm not. But I have to plug it in just to see the type of limit we are looking at. So when I plug in 2, the numerator is 4 plus 6. 4 plus 6 is 10. Minus 10 is 0. And the denominator is 4. Plus 4 is 8. Minus 8 is 0. I immediately say to myself, there is hope. No guarantee, but there are chances for the limit to exist. Okay. Now, I want to talk about a particular theorem. I'm not going to test you on this, but I would like you to know it because it's a very important theorem. Let me ask you this. 9 divided by 3. Everyone can tell me the answer to this, right?
3.
3. And what is the remainder?
0.
Of course. So whenever we divide the numerator by the denominator and we get a remainder of 0, so this is the remainder, we refer to 3. So this implies that 3 is a of 9. And you can say, what's the connection to that? I'll get to that in a second. After we establish this important word here, then you will see what I... Thank you very much. Why is 3 a factor of 9? Because the remainder is 0. Stay with me. What is the connection to this? Why am I even bringing this up? Here it is why. Here's why. If I have a polynomial, and I'm going to talk about the numerator. I have a polynomial which is x squared plus 3x minus 10. What did we plug in the polynomial? And we just got 0.
2.
2. That's what we plugged in, correct? Well, because when I plugged in 2, I got 0. This implies that x minus 2. So let me just say, come back here for a second. I can subtract 2 from both sides. And I can write x minus 2 approaches 0, which will be the same thing. When I tell you that x approaches 2, I'm telling you the same thing. X minus 2 approaches 0. So it means that x minus 2 is a of x squared plus 3x minus 10 of this polynomial. What is the word again that I'm missing there?
Factor.
That's it. Okay, again, how is this connected to that? Very simple. If I plug in a number, if I plug in -2, by the way, if I plug in -2 in a polynomial and I get 0, then the factor is x plus 2. Because then I have x approaches -2, which reduces to x plus 2 approaches 0 because you're moving it to the other side. So, again, why? Why all this? Very simple. I plugged in 2 in the numerator. I know that this has to have a factor of x minus 2. Same thing here. This must have a factor of x plus 2 as well because, I'm sorry, x minus 2, of course, because when I plugged in 2, I also got 0. So this helps me tremendously. I may forget how to factor, or who knows, it may be something difficult to factor. But I already know that both of them have to have at least one factor. They may have more than one factor. I don't know. But they must have at least one factor of x minus 2. This is called the remainder theorem. Okay, so from here, because I have all this in the middle, I'm going to jump here. And I have the limit as x approaches 2. Because I got 0, I have to have x minus 2 coming up. This helps tremendously. Understanding this theorem helps us tremendously moving forward, because it's so much easier. I know what I have to do. And eventually these two will go away. So now I only have to figure out what is the other factor. Because both are quadratic, I can only have one factor here and one factor here. So keep that in mind. This works only for polynomials. Don't try it with other functions. So it works for polynomial and polynomial. So what do we have here and here?
X plus 5.
Indeed.
X minus 2.
And x minus 2. Awesome. These two are gone. Now I have the limit as x approaches 2 from x plus 5 over x minus 2. After simplification, I plug in again. What do I get at the top? And what do I get in the denominator?
7 over 0.
So the numerator is
7.
yes, trouble. I know that chances now are 0 for this limit to exist. This, or this. This is always the case for a number over 0. Because the limit is from either side, I must determine the limit as x approaches 2 from the left and the limit as x approaches 2 from the right of this. X plus 5, x minus 2, x plus 5, x minus 2. I already know that this is 7 over 0, 7 over 0. I already know that they have to be infinities. No question. What I don't know is the sign. That's the only thing I don't know. So plug in, not in the numerator, because the numerator is always positive, around 2. But plug in the denominator, a tiny number closer, I shouldn't say tiny number, a number from the left of 2 very close to 2. And just tell me the sign here.
Negative?
Of course. Because a number from the left of 2 will be 1.9. And 1.9 minus 2 will be negative. Done. Positive over negative has to be negative. Now I need a number from the right-hand side of 2, very close to 2. Don't say 10. 10 is not close to 2. Say 2.1. And just tell me the sign. I don't even need your answer. Just the sign. That's it. Positive with positive is positive. So now I know the answer here. Because if both have the same sign, I have to write that. That's why I need to check both. Every time this is from either side, I have to check both, left and right. So what is the answer then?
E and E.
That's it. Very good pick. Thank you very much. This was a good one. So please remember this idea. 9 divided by 3 is 3. 0 remainder, it means that 3 is a factor of 9. Not this one. 3 is a factor. This can be 5. It doesn't care. I don't care. This one is a factor of this. When I plug in a number in a polynomial and I get 0, if I don't get 0, I cannot conclude this. I have to get 0. Then I know that x minus 2 is a factor. If I plug in negative 2 and I get 0, then the factor is x plus 2. Why is this useful? You can say, this is sophisticated. I don't really need this. Maybe I would agree with that, but this is saving us a lot of time. Knowing that when I plug in a polynomial something and I get 0, that has to be a factor. Good, very good. So let's go back. Let me share. Okay. So we haven't talked about continuity yet. I still want to see if we want to look at something else.
do 27?
Yes, let's do 27. Excellent. Excellent pick. Let's do that. I'm on page 2. 27. It's the square root. Oh, limit of the square root of x minus 5 over x minus 25 when x approaches 25. Perfect. Perfect pick. Thank you very much. Okay. So our first step is we plug it in. Why? Because it could be that I don't have to do anything and I just get the answer. It's a rational function. It's a combination of radical. Okay, so where does the numerator go?
Zero.
Perfect. What about the denominator?
0.
Yes. So there is hope. I'm not saying it exists. Like we had the same situation here a minute ago. There was hope, but we ended up with DNE. So there is no guarantee. Okay. Now, what do we do in this situation? We had an example when we looked at the function like this with a difference quotient. What did we do? I'm just going to copy it because I already wrote something there, so you don't have to if you don't want to. And here's my hint. Anyone remembers what to do with this?
Do we multiply by the reciprocal?
Very good. Thank you very much. Who was that?
Tyler.
Thank you. Rationalize. Thank you very much. The numerator. That's why we studied the formula a plus b times a minus b on the first day of classes. So the square root of x plus 5 and the square root of x plus 5. Very good. Thank you. Good. So I keep the limit operator. I did not apply it yet. Can anyone give us the numerator? I will copy the denominator.
X minus 25.
That's it. First term squared. If you forgot it, I hope you didn't. Please go back and review all the notes and always extract the important information from each class and put them in a little notebook, please. So the first term squared is indeed x minus the second term squared is indeed 25. Obviously, you're going to tell me what to do next. I have no doubt that you're going to tell me what to do.
Simplify.
Of course. Now plug it in.
One over 10.
That's it. So this time the hope materialized.
I'm a little confused how you got the numerator.
The first term squared minus the second term squared, according to the formula.
Oh, okay, thank you.
You're welcome. Is that clear?
Yeah.
Perfect. Okay, so let's see if we have anything else to look at. If not, we will talk about continuity. Let's see on the next page. Yeah, they are jumping into continuity. Okay, so I'm okay so far. Let's see if we can look at maybe let's look at 31 through 36. Any radical.
33.
33, let's take a look. 33. Limit x approaches 2 from this x squared minus 9. Now, this is a slightly more complicated situation. Can anyone give us the condition to find the domain?
it must be equal or lesser than 0
That would
or
be,
greater than
say it again.
equal to, or it's an inequality to 0, but I don't remember if it's less than or greater than.
But you'd only have to think of what I can take the square root from. What can I take the square root from?
A positive
ra-
number?
Yes, I can, and I can take the square root from 0. But the question is what? What do I put on this side?
The radicand.
The radicand, very good, x squared minus 9. Awesome. Thank you. So this is a different situation. Please do not move 9 to the other side and take square roots. No taking square root or square roots from both sides of an inequality. In an inequality, it's possible under certain conditions, but in general, do not do that, please. What we have to do is we have to factor, or you can graph. But what I show my students is like a little table of signs. To find the sign, I have to find the sign of this product. So I put the first factor in the table, the second factor in the table, and then the product of x minus 3 times x plus 3. Or you can graph, right? You can graph this function. It's x squared minus 9. So you know it's positive outside and it's negative where it's below the x-axis, right? Negative 3 and 3. So it's negative between these two. So the domain will be from this point to the right and from this point to the left. Or with this table, negative infinity, infinity. And we put the zeros. Where is this 0? At negative 3. Where is this 0? At 3. Careful, these have to be in ascending order. So then, you know, we study the sign. To the left is negative. To the right is positive. To the left is negative. To the right is positive. How do I know? Just plug in a number. Plug in negative 10. Both of them are negative here, right? And so on and so forth. So then when you multiply a negative by a negative, you get a positive. When you multiply a negative by a positive, you get a negative. When you multiply to the side of 3, to the right-hand side of 3, multiply two positives, you get positive. Since this must be positive, we have to choose this and this, meaning this and this. So the domain of this function is negative infinity to negative 3 union 3 to infinity. Again, you can say, what's all this? What are you trying to do? What about the limit? They're asking us about the limit. True, but when I look at a function like this, and I find its domain, look at the domain and look at this value. What will you say? Without
2
any...
is not in the domain.
Exactly. There is no discussion.